This lesson is an introduction to solving trigonometric equations. And when it comes to solving these equations, a lot of the skills you're going to use are going to be similar to ones you already know for solving other equations. So specifically, what I've written here tells you that to isolate the angle in a trig equation, you may have to apply commonly used skills to rearrange the equation. This is the idea behind reversing BEDMAS when rearranging any equation. And you might have to apply a trig identity to change the equation. Sometimes it won't be won't be written in a way that you can solve directly. So example 1, here we have we're being told to solve the equation 3 sine theta plus 1 equals 0, where theta is between 0 and 2 pi. So it looks like we should be able to isolate theta just by doing some rearranging. So I'm looking to isolate theta. So the first thing I want to do here is move this here, because it's not with the term involving theta. So the first thing I'm going to do is subtract 1 from both sides. So I get 3 sine theta equals -1. And working further towards isolating theta, we've got some multiplication here. So I'm going to use the opposite, which is division. So sine theta equals -1/3. And now to isolate theta, I need to take the inverse operation. So that will be the inverse of sine. So theta equals sine inverse of -1/3. And I don't know any exact answers for an equation like this, so I'm going to plug it into my calculator. So I'm going to inverse sine of -1/3. And the calculator has given me an answer of -0.3398. So that means it's given me an answer that is in the negative quadrant here. But I want answers that are in the positive. So I know sine is negative in both of these quadrants. So it's going to be 2 pi minus the answer we were given. So 2 pi minus 0.3398 will be one answer. And pi plus 0.3398 will be the other one. So I'm going to get 2 pi plus equals, okay, so this one here is 5.9433. And the other one we will have here, sorry, I'm just taking a second to make sure I plug this in the calculator correctly. This time we're going to add pi, and we get 3.4814. Okay, so those are my two answers, my two final answers. make it nice and clear for you there. So in our domain, to get the answer we're looking for, theta has to be one of those two things. And we can, of course, check the answer. You have a couple of options. So you can check by plugging it in. So if you plug in theta, make sure you actually get the answer you want. Or we could also try graphing. Both options would allow you to check that your answer is correct. Now we're going to try one that is going to force us to put an identity in, because if you take a close look here, we're told to solve an equation that has 2 theta and theta as options. So it can't necessarily do a simple collecting of like terms that allows us to just rearrange the equation, because I've got 2 theta and theta in here. So what I'm going to need to use is one of the double angle formulas, because we want to make sure that we've got either all thetas or all 2 thetas in here. So we're going to recall that sine 2 theta equals 2 sine theta cos theta. 2 sine theta cos theta. So that means that I can plug this in to here. So what I have now is 2 sine theta cos theta minus sine theta equals 0. Now I've got everything that just has theta in it. Looks like I can do a little bit of factoring here, which might work out nicely. So I can factor out the sine theta. So sine theta, when I pull that out, I get 2 cos theta minus 1. And this is set equal to 0. So that means that I have to either have sine theta equals 0 or 2 cos theta minus 1 equals 0. So either one of those options will give me answers that work. So let's start just looking at those. So we get sine theta equals 0 or 2 cos theta minus 1 equals 0. Sine theta equals 0 in that domain that we want. We're pretty much familiar with answers for this. So theta equals 0 or pi or 2 pi. You can always graph to remind yourself of those, or look at the unit circles as well. And our other option here, 2 cos theta minus 1 equals 0. So I need to do a little bit of rearranging. So 2 cos theta equals 1. Cos theta equals 1/2. And I should be able to come up with options where that happens as well. I don't often have the special triangles memorized, but I know really quickly that this is the one that would form that, where this upper angle here is theta, and that's the pi over 3 angle. And we're positive here, so theta is pi over 3, and it's also positive in the 4th quadrant, so 2 pi minus pi over 3 is the other option, which means that it will be at 5 pi over 3. So there is actually 5 answers in the end. Therefore, theta equals 0, pi over 3, pi, 5 pi over 3, or 2 pi. All of these things will satisfy the equation. And again, we can always check by plugging it back into the original equation.